Sounds good too.
Okay, so there we go. Delta H is equals the energy required to break the reactants bonds minus the energy released when the products bonds are formed.
That's a really long.
So for this one, we are going to look on page 424. Look on page 424 of your book.
Which book?
The one that's all wrinkled up here. This is the
Apology.
apology.
It took like 6 times to say that. Apology.
Okay, let me erase the top part of this so we can start calculating that. All right. So here's our formula. Here's our chemical reaction. Now, whenever we use a chemical reaction, what is one of the most important things that we've got to do?
Balance.
Excellent. You got to balance. Is that balanced?
Very not.
Absolutely.
We got one carbon here, one carbon here,
Well, we need
3 oxygens here, 2 oxygens here, 4 hydrogen here, 2 hydrogen here.
that needs.
Okay, so
How
the
we got
oxygen over there needs 2, and that one needs 1, and then that one go away. That one needs 2, and that one needs 2. Because that would get 4. And then that, the hydrogen on that side
H2O needs
needs
to
2,
be
and that
times
one
by
needs
2,
1.
and O2 needs to be times by 2. The other one's stay at 1.
What he
So we
said.
got 2 here.
I just made it very confusing.
Yeah.
And O2
And what else?
needs to be times by 2.
And
O2
then
times by 2.
CH4 needs to be by 1.
And
Well, that's-
iron
It's standard is 1.
I know, never mind.
That's
I was, yeah.
iron Grace Marie.
Wait, well now we have.
So I don't think that was our beep. I don't think we need 2 here. I have
Yeah, because you'll have 4 oxygens.
we have 4 oxygens up. Okay, yeah, we have 4 oxygens. Okay, 4 oxygens here. All right, very good. All right. So we got to come up with the energy required to break the reactants bonds and the energy released when we form the products bonds. How are we going to do this? Well, we're going to have to come up with some diagrams of what this actually looks like. So for CH4, we have to account for every single one of these hydrogen bonds. All right, so it looks like this. Right, so we have 4 CH bonds. Look in the table on page 424. What is the bond energy to break a CH bond? What's required?
411.
411. So 1 CH bond equals 411 kilojoules.
Whoa.
Those are in the air.
That's pretty cool.
Yeah.
What is?
Hey, right there's 99.
That's exactly what this is.
I think he's starting it on because.
All right.
Oh my god.
How about O2? What does O2 require, Elizabeth?
That 411 happens C-.
I don't.
It is 411 kilojoules per milliliter.
494.
494. Notice that we needed to know that O2 actually was O double bond O. Right? So
Oh, that's a double bond? I couldn't tell that. I thought it was just like.
did you give me the double bond or double single bond? Did you give me double bond? Double, okay. 494 kilojoules per mole. Okay, so that's our reactants, right? So we're going to add those up. We have 411 plus oxygen, but how many moles of oxygen do we have? Two. So it's going to be 2 times 494
Oh, this is easy.
minus the products. What's our product? CO2. What is the energy required to break a CO2 bond?
358.
I have a question.
Oh wait, O2, never mind.
How?
799.
Okay, I'm just gonna leave. Are you just throwing out numbers?
No, I'm
No,
legit reading.
What does CO2 look like?
Numbers and it reads from random place.
Yes.
Oh, CO2 looks like that.
Right, that's what I pulled. That's that.
Wait, no. What?
Never mind. If that's what it looks like, I'm doing it wrong.
How does it look like that?
Oh, is this where you look your I'm just totally guessing.
No. Cool. This is
Uh,
the Dutch.
How many bonds does carbon want to form?
Four.
1, 2, 3, 4. So how many bonds does carbon form here? 1, 2, 3, 4. Right.
Okay, but what? Let me write it down.
But there's two.
Oh, gotcha.
Oxygen, actually, remember this? Oxygen has 2 unbonded pairs of electrons. Lewis electron dot structures. Oh my gosh! Yes. So what's the bond energy of this? What are we going to use?
799.
That's what I said.
Is it 799?
That's what I said.
But we have how many of them?
Don't listen to Alexander.
So,
How many of them do we have?
would it be 488?
I gotta make sure you guys are giving me the right one. 799.
No. It's 14.
It's 799, but how many oxygen bonded to carbon do we have?
4, 2.
2. Right?
Yeah, 2.
1, 2. C double bond O. We got 1 C double bond O here. We have another one right here. So it's 2 multiplied by 2. Right? So that takes care of our CO2.
1,598.
Oh, that looks terrible. Looks like a. Okay. How about oxygen? What do we need to do there?
Wait.
Or not oxygen. H2O. What does H2O look like?
Well, if it's
What does the 494 stand for?
No. O with 2 H's.
What is 4?
Just a single one.
What's 494? There says 400.
494 has to be our second reactant, which is O2.
I have no clue what H2O would be.
Right.
It's 2.
Double bond O, double bond O is 494.
Because it's H2.
What? This is so
Wait a
messy.
second. Is A.
Can we just erase it all and do it all down?
All right.
No.
Okay, so we're going to break these things apart. We got CH4.
Okay.
Right, what's the bond energy in CH4? To break this, you've got 4 of those, right?
Yeah, exactly.
Right, so you got
411.
each one of these is equal to
1,644.
411. Hold on. 411. Right, kilojoules per mole. Right?
Yeah.
But we have 4 of those. Right, so we're going to come down here, we're going to put 4 times 411.
1,000.
Right? See that? How about O2? O2. You got O double bond O, and that's equal to what?
We are.
That was
494.
494.
Kilojoule
Yeah,
per
okay,
mole.
I only have one of those.
No, we have 2.
But we got 2 of them. Alright?
So it's 2.
We got
times-
2, so it's plus 2 times 494.
You heard us, Mr. Two.
That finishes our reactants.
And then the product.
And we're going to subtract now all of the product.
799 is the first one.
What was CO2? CO2, it looks like this. And we said that was equal to how much?
799.
99 times still.
799.
So 1,500
And we
98.
have,
98. And
we got 2 of those. So it's going to be 2 times 799 plus H2O. What's H2O?
H2O.
OH is equal to 459.
Do you have to ever memorize all this stuff?
No.
Oh my god.
Wait.
Hush.
Very.
But we've got 2 of those, 2 moles of those, right? So it's going to be 2 times 2, 2 times 2 times 459. Wow. All right. Why? Because we have 2 moles. Why? Because we've got 2 CO2s.
Beautiful. I
You good?
understand it completely.
Cool.
Awesome.
They're not CO2s, those are OHs, I'm sorry. I'm sorry, OHs.
This is so much better than one-to-one ratio.
Yeah.
By a lot.
Someone plug and chug that, what do we get? I better plug and chug that, it's gonna be.
My calculator is the
Pardon me, Oscar.
brain of 2 girls, so
I don't think that's a good idea.
All right, so we should come up with 4 times 411
6. Ah.
plus 2 times 494. Our reactants look like 2,632 minus 2 times 799 plus 2 times 2 times 459.
59.
3434 2632 equals a negative 802 kilojoules per mole. Everyone get that?
Totally.
Yeah.
So, is this reaction exothermic or endothermic?
Indo.
Positive. Positive. Delta H equals endothermic. Endothermic. Negative delta H equals exothermic. So this is negative. It's exothermic reaction.
So what's the complete answer to that equation?
This complete answer is negative 802 kilojoules per mole. Easy stuff, huh?
Oh, yes.
For sure.
Definitely.
Let's try another one.
I love it.
We just burn something to figure out.
Who is this man?
amazing.
So why? I love him. Now I need his address. They can phone.
No, so we continue with that.
Okay. What do we got? Calculate delta H.
Wait, is this a new problem?
God love you. Calculate delta H.
Okay. So C out, it's not balanced.
Wait, we actually, do you want to? Yeah, I was going to say, can we just write it on the board?
So we're gonna do like the same thing we just did.
Pretty much.
Exactly. It's so tough to balance that one. Let's see.
Thank you for understanding.
Multiply by
I think we
16,
need to-
divide through by the square root of Planck's constant.
Okay, now you're just making it confusing.
Confusing me now.
I thought I knew what balancing was.
Would it be C
just
Oh,
2 in front of HCl.
Yeah, that's what I'm thinking.
Okay, good. All right, everybody agree with that?
Yeah.
If you say no, I will kill you. I know where all of you live.
You what?
Your season messed up now.
My seeds are messed up. No, my seeds are perfectly fine.
I was
You got one
actually
seed.
thinking of C.
Two on the
That's the
product
side.
No, what?
No, I got 2. 2 CLs, 2 H's. 2 CLs, 2 H's.
Okay.
What do we call these special kind of atoms that bond to one another, that bond to themselves?
40 times 2.
What do we call them? We call them diatoms, diatomic. What are you watching?
Nothing.
Are you texting one of them?
No.
No. I think I heard
Oh, that's a good idea.
Good one.
Legit. There's no gum in my class. I better not find gum stuck to the bottom of my pool table.
That would definitely be something Madeline would do. She doesn't even think around. She just like forgets to spit out her gums. She's just like. It's very bad.
Okay, so what's our formula? What's our formula?
Our formula is
It would be 432 times 2. Oh yeah.
Reactant.
energy
You forget to
required.
Minus product.
She go to the table and buy it.
Are you kidding? I don't have going there.
What's the
Come on, be that easy.
what is the delta H of Cl2 and H2?
Wait, hold on. I had this one because I just.
That's
428
CH.
times 2.
H2.
428 times 2.
8, 6,
Does, you want what? Ask a question.
I want what is the delta H of Cl2 and H2?
428 times 2. No, it's 428 times 2 because it's.
It's just CL.
No, because there's 2.
They don't have that
So
one.
I multiply.
Are we on CL or are we on HCl? I'm on HCL. That's why.
Let's see how much.
CL.
2 Cl.
Oh,
Cl2.
that's
Oh,
240.
240. H.
Oh,
Right?
gotcha.
240
So we would structure that.
plus what's H2?
I have a question. Whenever we did the last one, we did like CH4, comma, C dash
That'd be 432
H.
times.
Wait, it's
CH.
240.
CH, but you have 4 of
So how would we
those. Right, you got
structure that?
CH4. So you got 4 of those CH4s. You got 4 of them, 4 H's bonded to that carbon. So you have to account for each of those bonds. Because those bonds are what's getting broken.
What?
What do we got? What else do we need? We need that.
Wait. Is it
What's the
240
delta
times
H?
2?
It would be 240 times 2.
240.
It's just.
Oh,
240.
so we need
This
to-
is 240.
Ah,
Wait, where are you getting so 240 on this chart.
Oh, that's right.
Okay, 40 kg per mole.
424 on your apology.
432 is the next one, right? It's just 432. We're not dividing it by 2.
And then H2.
Of H2?
Would be
What?
432.
432? Alright, so this is Cl, Cl. This is H, H. Right? Minus all the products now. Well,
Which
there's
is
only one product,
428 times 2.
which is 428.
Times 2. Now you got all kinds of messed up.
Yeah.
Okay, how would we do
Alright, because we have 2 moles of it.
Okay, 30.
HCl 428? Okay.
Alright, but look, we got 2 moles of the gray, so you gotta count for the 2 moles.
Right.
Alright? Alright, so what do we got? 240 plus 432 is 672 minus, I don't know, what's 428 times 2? It is 856.
Okay, like.
So what is our delta H for this reaction?
672 is equivalent to 856.
672 minus 856.
That's what I meant.
Okay, so it'd be negative 174.
Negative 184
What are we talking about?
kilojoules per mole.
Don't you put KJ? Okay.
The answer is negative 181.
Is it exothermic or endothermic?
Endothermic. Wait,
So.
exothermic.
Exothermic. Is that like easy or what?
Exo. Endo.
That's really easy. Are we done?
Nope, we got one more.
That's cute. Wait, like a practical problem or something else to learn?
Something else to learn. We got the third way to calculate enthalpies. Remember, we have 3 ways to calculate enthalpies. One that never gets used anymore. That was the calorimeter.
Wait, did we just learn
Okay,
that?
so that was
The one
immediately
that
hard.
never gets used?
We didn't really learn it. We
No, that
looked
was-
at it.
The one we just
That was
did.
the-
No, this
That's the problem.
this kind of gets used if you can't find the heat of enthalpy of formation. If someone hasn't done the actual experiment for you, then you go back to bond energies. But you know, rarely is there a reaction out there that you won't find the enthalpy of formation.
Are we gonna go to the third way to calculate?
That's what we're doing. Ready?
I caught that.
Let's move on. That was so easy, so easy. It's so easy to calculate enthalpies. It's so easy to
Y'all.
calculate enthalpies. It's so easy. It's so
You would like
Third way, yes.
Thought about this.
Third way. And that is using enthalpies of formation.
What?
after next.
They were so mad.
Doll.
Oh my god.
Oh my god. Is right.
What about?
Using enthalpies of
Wait,
formation.
y'all
Yeah.
4-2.
What about you?
In order to use enthalpies of formation, Hess's law must be employed.
We beat Hugging Pussy.
We did too. We were in competition.
Quiet down, quiet down, quiet down. Pay attention. I'm gonna have my proctor go around and beat people. Proctor, go and beat people.
Use your steam airsoft gun and shoot us whenever we
Is
go.
Hess
I can go get one, Dad. We also have
Hess, Hess is gone.
Dad, you want
You
me
know
to
there's
go get
Oh,
one?
they're so sexist.
We can all see who's darts.
What?
We can all see knives.
You know, he was the one that did it, I'm sorry.
I'll be a female triple G.
Wait, knives? What was it?
Yeah, like we.
I mean,
Don't worry, I'll
this
give you
thing
credit.
fairly accurate.
Yeah.
Oh, excellent.
Effective list times.
Okay, Hess's law. Basically, Hess's law just states that enthalpy is a state of function. Enthalpy,
State of mind.
I'm gonna just write this down and explain. Enthalpy is a state,
Like gender.
You know, they actually added something to the LGBT. It's now the LGBT.
and it
Q for
is
queer. It's when you don't know what you are.
No, it's
independent.
actually LGBT.
It's
like-
FAA.
Well, okay, but the smaller
two
one.
S's.
Way.
Yeah,
I
the smaller
do
one
believe.
right now is just LGBTQ.
Queer.
They've been having
Are
that.
you queer, Alexander?
Yeah, far from.
Grace. How queer are you?
I've seen.
Yeah,
I've
it's
We call it bi.
a function of
What?
state. Enthalpy is a function of state.
No, that's already in there. That's something else.
State of function.
I think it's a function of state.
Who is whiteout?
Hold on.
I don't think Mr. Mike messed up.
Enthalpy is a state
Shame.
function. That makes any sense. Okay, enthalpy is a state function. All right.
Causing all the steam of
Yeah, that's.
Okay, basically what this says is that any way you form a molecule, its enthalpy, its formation enthalpy will always be the same. Will always be the same. Right, so I can form, or be an example of different ways to form something. If I do